Okay, so yesterday I gave you all activity 1.1 question 2 to do and activity 1.2 question 1 to do. Did you do it?
Yeah.
Try.
Okay, let's do it now, right? So I'm going to look at activity 1.1 question 2. You all managed to get access to yesterday's class video, right?
Yeah.
And then what was the issues with?
Sorry?
What was the issue with it? Like, was there any
The guys watched, they said the board wasn't too clear. They
So,
couldn't see the
two
board.
things. We remove this thing now, right? Bloody. Right?
Because the problem with that is because it goes in and out of focus because it picks up as we moving with that, right?
But I think this will cancel out the projection.
Yeah, and I tried to write a bit bigger. I think Avi told me because lighting was a good spot. Because being here is one thing, but watching the video is
Your kids is a little bit darker.
Darker.
Yeah.
I think this is darker.
New ones, yeah.
Because
That's
now you
fine.
got new
I think
players.
those other ones yesterday, I think.
It was dying as we were using it, right? Okay, so we're looking at question 2. So they tell you a river is flowing due south at 3 meters per second. So your river is now flowing at, so I'll say velocity of your river is equal to 3 meters per second. And then they tell you that a motorboat has a maximum velocity of 6 meters per second in still water. What did they give you?
It's the speed relative to the ground.
To the ground,
No.
Relative to the stream, to the
river.
Yeah.
Right? That's what they basically gave you. They gave you the velocity of the boat relative to the river,
Yeah.
which is equal to 6 meters per second. But they never give you any direction on it. That's why they refer to it as still water. So this is the set of information they gave you. And then they ask you to calculate the relative velocity of the boat with respect to the river bank. Now your river bank would be what?
The ground.
The ground. Right? So they're basically asking you, so you're required to prove the velocity of your boat to
Ground.
the ground.
Sorry, but you said the boat was being down.
No, but now we're coming to that
Coming to
part,
that,
right?
yeah.
We're coming to that part.
Okay.
Right? So, then first thing now, let's take our directions. So remember yesterday I told you for consistency amongst the class, let's always keep north as positive and east as positive. Okay? So in this instance here, we're going to take north as positive and south as negative. So, using, so this will be A. The first thing they tell you is, the boat is moving downstream. So if the boat is moving downstream, right, your velocity of B relative to R, which is a river, would it be a positive or a negative value? It will be a negative value. Okay? So, yeah, we'll come back to that part. Velocity of your boat relative to the
Maybe put
river.
the arrow in because to show the boat.
Yeah, maybe do that, I think.
Put the arrow in.
Down. Yeah.
Okay, so now for this first one for A, it's going to be moving like that. Right? So, your velocity of your boat relative to your river is equal to, what's the formula we're going to write?
Velocity of the boat to the ground
Boat to the ground,
plus the velocity of the ground to the boat.
ground to
To the
the,
river. To the river.
right. Then it will be velocity of your boat relative to the ground minus velocity of the river to the ground. And this is V. Right. What would this value be?
It would be minus 6.
Minus 6, right? Because we said it's moving down. Down would be a negative value. So this would be minus 6 equal to the velocity of the boat relative to the ground is what we're trying to work out. Minus what would be the velocity of the river relative to the ground?
3.
3.
-3.
Minus 3, right?
Minus.
Where the river is moving? Down. Down is negative. So this would be minus 3. Negative and a negative gives you a positive. When you take this positive across, what will it become?
Plus.
Negative. So it become minus 6 minus 3 will be equal to the velocity of the boat relative to the ground. And then minus 9 meters per second will be equal to the velocity of the boat relative to the ground. So it will be 9 meters per second south.
I missed the science.
The science, see that's what we capture. But do you ever understand how we work this out? You understand?
Understand now.
Now once you did it, right?
You see,
But-
to get this bottom stuff, you see, it's getting there. You need to
Yeah,
select
yeah.
this,
So
Understanding the question.
Yeah.
And the only way you're going to be able to understand it if you keep on attempting more examples, because once you do it, you'll be able to get that knack of how they answer. Okay, let me do B and then we'll take it on that. So here's a B. Yeah, the boat is moving upstream. So now your boat is moving that way. Okay, so for B, we're working out the velocity of the boat relative to the river will be equal to the velocity of the boat. It will be the exact same thing for those two parts, right? But you'll see where the change is. So I'm just going to write that down. That's the velocity of the ground to the river equal to velocity of the boat to river, velocity of the boat to the ground, and the velocity of the river to the ground. Right. Now because the boat is moving upstream, what should be this value?
So you want to draw the arrow.
Positive.
And-
Positive.
Oh.
Right? What will be the value? Positive. It will be positive 6 equal to the velocity of the boat relative to the ground is what we are working minus what will be this value? Velocity of the river relative to the ground. It will still be negative minus 3 because there's the river. Right? 3 and because it's moving down to be negative 3. So this negative and negative will give you a positive. You're going to end up with 6 plus 3. No, minus 3 when you take it across, right? Be equal to velocity of the boat relative to the ground. 3 meters per second will be equal to the velocity of the boat relative to the ground. So everybody understand that? Everybody understand what we did?
Got the right, but this number, these things.
And writing it like
You
this.
know, VP relative to
What's it?
How to read it?
The thing is that when you're all doing it, try to do it exactly like how I do it in the board. The more you attempt it, after a certain point when you get good at it, there'll be certain steps you can skip through. But for now, let's try not skipping through steps because when you skip, you forget. Right? You skipped and you forgot. Of the formula.
You get confused with subjects.
Yes. This true relationship, all the subjects is missing.
Then measure relative, what is it all relative?
You have to remember which subject you
To make sure that, because see, we're working with relative velocities. Everything, remember when we said earlier, everything is relative to something. Even if it's only one object moving, that object will be relative to the ground. So everything is relative to something. So whenever you see that comma, it's relative to something. And then from there, it's not given because it's a comma, it's a comma.
Hey, just a reminder, this is a comma, right? Not a I. Then semicolon.
Yeah, some people thought it was I, yeah.
Yeah.
BP.
Can you just use a colon?
Yeah.
Much neater.
As long as you get the right answer, I don't care what you use in between the thing, as long as it comes to the right thing.
You said just like this one, okay?
But it helps to for that.
Yes, yeah.
So like the creativity 1.2, that question something like that.
And
But with the angles, but we're gonna do one
that one is confusing. I think once you do one plus one plus, this method here.
And this method is a better method than the other one with the sine rule and cosine rule because that sine rule, like I'm going to show you that later on, that's nice for resultant velocity. In terms of relative, because you work looking at one point relative to another, the way you draw your diagram
Get confused with the angles as well. So this way, I think it's better.
because you break down each thing and you're not doing too much with the angles, just one set thing and then you're out.
No, come back.
Yeah. Guys, you're very done. Yeah, I'm not very done. Yeah, also if you don't finish taking it down here, remember you'll also will have the video later on. So this thing, so we can try to get more out of the time that we have left. Okay, let's look at the next one. So we're looking at activity 1.2, question 1. No, 2. What happened?
Question
Okay,
one.
question 1.
Question
That-
one, yeah.
So, can I take some?
Yeah.
I'll take it.
Oh yeah, even a picture and then later on you can just copy it down again, right? Got it. Right, so they tell you there that an object A is moving due south past a point at 12 meters per second. So, object A is moving due south. Velocity of A is equal to 12 meters per second. Past the point 12 meters per second, while object B is moving due east at 8 meters per second at the same point. So, object B is moving there. Velocity of B is equal to 8. Next. Calculate the velocity of A relative to B and the direction. So let's choose our sides. This is going to be north as positive, south as negative, east as positive, west as negative. So they want us to work out the velocity of A relative to B. So it's the velocity of A relative to B. Now, remember this is non-parallel. Okay, so what we need to do?
HC and VC.
Our vertical components and our horizontal components. So, the first thing you will do, you will break these up into its vertical and horizontal components. So, you're going to say the velocity of A relative to the ground along your x-axis will be equal to what?
0.
It will be 0. And remember units, guys, please. The main thing in engineering science too is units. You can do all your answers correctly. And if you put the wrong units, they will mark the entire thing wrong. Right? The velocity of A relative to the ground along your y-axis will be equal to what? 12.
Negative 12.
Negative 12. Remember we said down as negative. Okay? Negative 12 meters per second. The velocity of B relative to the ground along your x-axis will be equal to what? 8. Positive 8, right?
Yeah.
And then the velocity of B relative to the ground along your y-axis will be equal to what? 0 meters per second. Now that we have this, we can start working out our vertical and horizontal. Okay? So, we're going to say V of A relative to B along your x-axis will be equal to what? We need to break this up.
V of A
V of A,
relative to G along the x-axis.
yes,
Plus V of G relative to BX.
on your x-axis. Everybody understands this, right? Oh, we got this. Okay. So our next point, we want to make both relative to the same term, which would be your ground. So now we're going to say velocity of A relative to the ground along your x-axis minus the velocity of B relative to the ground along your x-axis. Now we substitute our values. What's the value for velocity of A relative to the ground along your x-axis? 0. Minus the velocity of B relative to the ground along your x-axis? 8. So this here will work out to minus 8 meters per second. Now let's do the velocity of A relative to B along your y-axis. This would be equal to what?
Velocity of A
Velocity of A relative to the ground along your y-axis
plus velocity of the ground relative to B along the y-axis.
Yes, right? From here we make both relative to the same terms. That will be velocity of A relative to the ground minus the velocity of the
B.
of B relative to the ground along your y-axis. Now we substitute values again. What will be the velocity of A relative to the ground on your y-axis?
Minus 12.
Minus 12 minus 0. This would come to minus 12 meters per second. So now we have these two parts. We can now get our triangle, so we can do theorem of Pythagoras. So right, your x-axis, you got a negative value. So where it will be found? On the left side over here. Okay, so this would be, okay, let's say this is 8, right? This is 8. Okay, and your y-axis is a negative value as well. So now you will come down. Right, so this here is 8, this here is 12. The resultant of this will be in what direction? It will come there. Let me go a little more. Right, so this value here will also be 8, that will be 12. Why would this be 8 and that, why would this be 12 and that will be 8? Because it's a parallelogram. So this line here will be what line? Your velocity of A relative to B, your resultant there. So this will be velocity of A relative to B. Okay, now we can work it out. How would we work it out?
10.
At 10.
Oh. No. It's
This value?
velocity of A.
So you're gonna say velocity of A B squared is equal to the velocity of A relative to B along your x-axis squared plus
velocity of A
relative to B.
relative to B along x
squared. Right. So this will be equal to your velocity of A relative to B along your x-axis is what?
H.
You can just say 8, right? Because it's gonna
It's got a square.
square itself up, right? Plus
12.
12 squared. And then I'm square rooting this entire thing because of that square there, right?
Yeah.
So velocity of A relative to B. Velocity of A relative to B works out to what?
14.
40.422 meters per second. Now we worked out the magnitude. Now we just need to work out your direction. Okay? Let's use our angle as that point. Okay? How would we work this out now? We would say 10 of your angle will be equal to, so it will be your VAB on your y-axis all over your VAB on your x-axis. That would be your formula, right?
Yep.
Right. So your angle will now be equal to shift 10, value of VAB on your y-axis, 12 over 8. And what you get?
1.5.
How do you do it? How do
How do you put
you
this into your calculator?
calculate? That's why I made a
So
problem.
everybody take out your calculators.
Let's give us 56.
Yeah. What it is? 56 point?
310.
Calculator.
I got mine.
310. Okay. So you want to know how to put it, right? What you would do, you would press shift in your top left side. Shift
Yeah.
10. So when you press shift 10 on your calculator, you're going to see this part here, 10 to the power minus 1 with the open bracket.
Yes.
Then you press the fraction button and you put 12 over 8.
Fraction
You
button.
take out your calculators, guys, if you're going with your.
Call.
Yeah, above it. Above it. That's showing the shift function. If it's yellow, it means it's shift. And if it's in red, it means you must press alpha to get to that.
It's
There's 10, yeah.
inverted.
10, yeah.
10 minus 1.
Oh, what inverted?
Where's the calculator? That's why. Get him with the
Okay, so
calculator.
for this calculator, what you're going to have to do is put your numerator first. So you put numerator fraction over 8. Okay, so your one you don't have to
Yeah,
yeah.
so it's,
You put for your one, you'll have to put the numerator first. So you shift it to 10.
1 over x.
then I said that the area
Check it out. We need I know okay, I made this 18 times before. We need
Yun na yung fraction law 1 over x.
for all the subjects. Calculator.
You see, maybe then you want to start with the numerators. Yeah. No, so
But then function
to show you
Your system is controllable.
what we're gonna actually use. No, we do know because you're not gonna use it.
Siya long ito.
Functions here for your sine, cos, and tan. Everything above it, your fractions.
What differentiation?
Like traditional, this is how to pounds to the
Yeah. So it should be right here. You get your button right there. So the button is not reaches. So shift fraction button. Then you press 12. Put 8. Okay, guys, everybody understands that, right? Right, we're not done with the question. So, is this your final answers? No. We need to basically state it now, how it is moving. So, the velocity, okay, so therefore the velocity of A relative to B will be equal to, your magnitude is 40.422 meters per second. And now your direction. How would you write that down? You would say west 56.310 south, right? That will be your answer. Okay, everybody understands what it is there? It's much easier, right? Much easier.
Just 1 minute. On this computer now.
Wait, let me just put
That's how I stopped.
Yeah.
I thought I was doing the wrong thing.
No. And also the way your diagram is drawn out after that will be in opposite direction. Your magnitude will always be the same. Because remember, A is the same distance away from B as B is to A. But they are different in your directions. So that's what you want to basically is, right?
It's the opposite of west and south.
But if you have to look at it, right? This was velocity of A relative to B. So from B, this would be southeast, right? I mean southwest, right? If you're standing here, this would end up coming to northeast.
So that's how we change.
Yeah, but the angle value will be different.
Yep.
No, but I got the angle value.
Yeah.
Let's just do it, right?
Yeah.
So we're doing B, which is the required to prove the velocity of, what's the question? Velocity of B relative to A.
Yes.
Okay, so it's velocity of B relative to A. I'm not
And
working this part here out again because it's going to be the same thing
the direction.
that we have over there,
Yeah.
right? So this now would be velocity of B relative to A along your x-axis would be equal to what?
Velocity of B relative.
Velocity of B relative to the ground along your x-axis plus velocity of ground relative to A along your x-axis. We're going to make both relative to the same term, which will become that, and then we substitute. So velocity of B relative to the ground on your x-axis is 8. This thing is dying. Right? Minus the velocity of A relative to the ground along your x-axis. 0. So now this value works out to 8 meters per second. Now, velocity of B relative to A along your y-axis would be equal to velocity of B relative to the ground along your y-axis plus velocity of ground relative to A along your y-axis. This will be equal to velocity of B relative to the ground along y-axis minus velocity of A relative to the ground along your y-axis. So for everybody with me, right? Okay. Value here 0 minus 12. So this will come to minus 12. So let's draw our diagram. So your diagram would be 40, what?
The board is 40.
Yeah. You're done with it, right?
Yeah.
You can take it. You can take a photo of it.
Yeah. Mine side to be black and mine to be
Yeah, post it.
You can post the stuff that we do in engineering science on the engineering science group, right?
Post your one.
Okay, I got the picture. Let me just check this out. Right, so now we're drawing that diagram. So okay, now we worked out. Yeah, we right. Yeah. Okay, so now we need to draw our vertical component and our horizontal component. How would we do it? Your x-axis would be what? Positive 8. So where would it be? Here? Would it be here? No. It will be here.
Yeah.
Right. So this would be 8. And your y-axis has negative 12. So it will come down here. Right? Okay. So your resultant will come something like that. You all agree? Okay. So this here is V of B relative to A. This value here is 8. This is 12. This is 12. This is 8. So now we have all this. We can use theorem of Pythagoras to work it out. So your velocity of B relative to A squared would be equal to the velocity of B relative to A along your x-axis squared plus the velocity of B relative to A along your y-axis squared. This will be equal to the square root of 8 squared plus 12 squared. And you'll still come back to that same answer we got of 14.422 meters per second. If you're ever working this out, right, and they give you two questions like this, and if you come to a different answer here, then you know you did something wrong, right? Because, like I said earlier, A is as far away from B as B is far away from A. Okay. Now that we have this, we can work out our angle. So which side do you call? Top.
Yeah.
Okay. What do you mean lectures this markers are finished? Right, call it that. So tan of your angle will be equal to the velocity of B relative to A on your y-axis all over the velocity of B relative to A along your x-axis. This angle will be equal to shift tan of 12 over 8. 12 over 8. And what you get? You get the same thing again. 56.310. If you did take it as 8 over 12, it's also fine, provided that when you wrote your answer out, you said south, the angle east. Okay? So now this answer here will now come out to 14.422 meters per second east, 56.310 degrees south. Right? Anybody has a problem with that? Does everybody understand what it is?
8.69.
Yeah, even
Yeah.
my one, see the signs.
This one?
I have the opposite way, but the answer still came out the same.
Yeah, see, because you did your method correctly.
Yeah, you fine. Yeah.
So you see, either way, regardless. I just said let's do it like this because when we're all working, it saves you from having to do it 4 different ways. We'll all work it on the same way. Right? Now what to do? Something about this.
I'm fan of donuts. Fun now.
The setting one. You want to practice to do it.
It's, see, for me, what he's got there as negative this side and positive this side, and on the other way around, but the answers are still the same.
No, but then it will be. But did you get the direction right? Or?
Yes, the directions are right. The only difference was, you know, on the y-axis, it's not 56, it is 39.
Oh, but okay. I posted it.
Of
It's posted.
okay, cool.
So the one that I get 100% corrections. Oh, but like this one, the way it's writing it, I think it's like that. So I'm going to redo it, writing it.
Yeah.
Okay, so far out of everybody, how many of okay, all of you attempted it, right? How many of you have got it right? First time, how many of you were close but made like a mistake somewhere that messed up? See, but you're getting there, right? You're learning the method as to how you would answer these questions. Okay, now I want to do example 1.6. So yesterday we did example 1.5. Now I want to do example 1.6. Example 1.6 is more likely the stuff that they would ask you, right? The way the question is. Okay, so I'm on page 11. Okay, so they tell you that car A is moving due east at 40 kilometers per hour. So car A, velocity of A is equal to 40 kilometers per hour. And car B is moving at 60 kilometers per hour in a direction 30 degrees south of east. So southeast is somewhere here. Velocity of car B is equal to 60 kilometers per hour. Where would your angle be? South of east. Where would your angle be from? Is your angle here or here? Inside. How is it inside? South of east, right? So it starts at east and it goes south. Okay? So the angle here, actually that direction, is 30 degrees. Now we got the information that they gave us. Everybody understands how we got it there? Okay. Let's do our directions. I'm going to take north as positive, south as negative, east as positive, west as negative. Okay. They want you to calculate, so you're required to prove the velocity of B relative to the velocity of A. Now this is exactly like how we would have started our earlier question. We'll work out the vertical component of each line, the horizontal component of each line, then we'll work out the entire part, right? So we're going to break it up. So let's start with that line first. So we say the velocity of A relative to the ground along your x-axis is equal to what? 40. Positive 40, right? Because it's moving in a easterly direction. The velocity of A relative to the ground along your y-axis would be equal to what? 0 kilometers per hour. Now let's go to B. Velocity of B relative to the ground along your x-axis. How would we work this out? Now remember last time I told you that these lines all have a vertical component and a horizontal component. That vertical component and horizontal component gives that resultant line, which is this. So this line, the same line here, can be broken up into basically that plus that, right? And this is our angle. Okay, now remember I told you when we were doing the trick how we would get the sides. Remember, sine is equal to opposite over hypotenuse, and cos is equal to adjacent over hypotenuse. If this is your hypotenuse, where your angle is, this would be your adjacent, this would be your opposite. Now, if you had to look at it, your adjacent over hypotenuse would give you its, your adjacent is basically your horizontal component, and your opposite is your vertical component. Remember I told you at that time, I told you when you're working your vertical components, you'll always use sine. When you're working your horizontal component, you will always use cos. Now remember, your opposite layer for here, where we said that this here will give you your horizontal component. So this formula here, sorry, it's supposed to say sine? Angle? Yeah? Angle. Right. This formula here can now become hypotenuse times sine of your angle will give you the opposite side. And the same thing here, your hypotenuse times cos of the angle will give you the value of your adjacent side. Right? Which is exactly what we're going to do with this line here. This angle here is now, okay, let me keep that.
30 degrees.
This angle here is now equal to 30 degrees. This hypotenuse is now 60 kilometers per hour. This adjacent is your velocity of B along your, no, don't confuse yourself. It is not 40. It is not, this line has nothing to do with that. This line here is breaking up this line into a horizontal component and a vertical component. Please don't mix it up. Yeah, we're just trying to solve for each of its parts that will give you that. Is anybody getting confused with what I'm saying?
No.
It's fine.
Now we back.
We're back. It's good. Don't. That's why I use a different kind of thing, because I basically showed you I pulled this line out and I broke it up into two parts. Okay? So this is now your velocity of B along your x relative to the ground along your x-axis, and this is now your velocity of B relative to the ground along your y-axis. Fine?
Yeah.
Fine? Good. Right? So now, to get your velocity of B relative to the ground along your x-axis, it will be equal to what?
Cos. Horizontal is
Opposite over hypotenuse.
It will be sine, right? I told you for horizontals you always
Sine.
use sine. We're looking at this part?
Yeah, okay.
Yeah. No, sorry.
Oh, man.
It'll be cos. It'll be
Cos.
cos. Because we are looking at this part here.
Yeah, the
We
adjacent.
are working out this.
Adjacent.
Okay. So this will basically be equal to 60 cos of your angle, which is 30 degrees. Yes?
Yeah.
Everybody understands it? Okay, fine.
And I'm a bit lost, but it's,
Okay, which part you lost?
from the 40.
40.
So the one you're explaining just now to
One you were
say,
explaining why
you don't-
mustn't confuse it.
No.
Drawing, just drawing.
So you draw a second, you make a second drawing.
Yeah.
You don't have to make a second drawing. I'm
Just
showing
to
you
just to remember.
how this here basically comes.
So why we use the 60 and not 40?
Why goes
Because
so see right?
If the question was being reduced proportion.
Yeah, so remember this line has a vertical and a horizontal component.
So
Yes?
yes.
Which we worked out here.
Okay.
Now we're looking at only B, velocity of B. Okay? Velocity of B also only has a vertical and a horizontal component, which is what we do at the start of these questions when we work it out, right? So now because I'm solely only looking at the velocity of B relative to the ground, I'm only going to consider this line here. What these red lines here are basically me showing you how this black line breaks up into a horizontal component and a vertical component. Understand?
So that is why I was saying to make that for yourself.
Yeah.
To make that drawing, it will help.
Yeah.
So that you won't confuse it with,
With this here.
Yeah.
Right? And if you want, you can go with other colors to the, well, don't write in your exam with other colors, but even if you take your pencil and a black pen and you use it. It's the same thing. You can use a pencil for where I had red and the black pen for where I got black. You know what? So you don't confuse it. So I'm just basically showing you this to show you how I'm breaking it up and getting to these parts here. Okay? So this will be the values, right? What is it?
30.
30 meters, what do you know? Kilometers. Kilometers per hour. Fine. Cool. Right. Velocity of B relative to the ground along your y-axis, which is your vertical component. When we work with vertical, what are we using?
Sine.
Sine. Right. So what you would start off with first, you would start off with the magnitude, which is?
Okay. I used the wrong one. So I didn't use cos on the top one.
Yeah, so horizontal is always cos, vertical is always
Yeah.
sine. So what
So
will it be?
30.
The magnitude?
Yes?
60.
60. Is it just 60?
60 kilometers per hour.
Is it just 60? Guys, pay attention. Don't write. Give your time after that because you need to get this before you write, right? What will be the value of the magnitude?
Let's correct the top part first. It will be that cos of 30, 60 times cos 30 is not 30.
51.96.
No, it's just to do an answer to
Cos 30, 1.866. Times of 60.
But that's the is actually, I think, the
This is 51.962.
opposite.
51.962 kilometers per hour. Right?
Yeah.
Okay. Your magnitude for velocity of B relative to the ground in your y-axis.
Yeah.
What would be this value?
Negative.
Why it should be negative? Because look at the way the shape of this line is going.
Going down.
This will also affect it, right? So it will be now, because remember here it was positive because this line was moving in its horizontal component was moving in a easterly direction, right? And we said easterly is positive. Its vertical component is moving in a southerly direction, which is why we are saying it's negative. So this will become minus 60 sine of 30 degrees, which will come to what?
Minus 30.
Minus 30 kilometers per hour. Does everybody sitting here understand what I did here? Because the next part here is basically what we did in our other questions. The main thing that's different from what we did in our other questions is that. But does everybody understand what I did there? No, it's when you
So for as long as your line is not sitting on the equal y-axis, that's when
you'll break it up into its parts. And as you go later on, you won't even need to draw this anymore, because the moment you see this, you would know that it's going to be the velocity, that it will be your magnitude, and then for your vertical component, sine of the angle, horizontal component, cos of the angle. But also remember the direction in which your line is going will also depict whether you have a negative magnitude or a positive magnitude. Okay. Can I carry on? Okay. Let's go. So after this point here, what would we normally do?
You work out your result with your A. What's the question? A relative to B. So you write out a formula.
A relative to B. What's the question?
B relative to A.
E relative to A. So now you'll work out your vertical and horizontal components. So this will now become velocity of B relative to A along your x-axis. Break it up. How do we do that?
So it will be B velocity of B to the ground
To the ground along your x-axis
plus the velocity of the ground to A along your x-axis.
Right, so now we make both relative to the same term. So this will become velocity of B relative to the ground along your x-axis minus the velocity of A relative to the ground along your x-axis. Substitute your values. This value here is 51.962 minus 40, which would be 11.962 meters per hour. Right, now we got our vertical component. Let's do our horizontal. Remember this part here is exactly like what we would do in our other questions. The only thing that we did differently was use cos and sine to get the individual components for B. Okay? So, velocity of B relative to A along your y-axis will be equal to,
Velocity of B to the ground on the y-axis
yeah,
plus
That's
velocity of the ground to A
along your
the
y-axis. And you see, the more you say it while you do it, even in your paper when you're writing, you'll be singing that song in your head. Velocity of B relative to the ground along your y, and you just keep on going like that, right? And before you know it, you'll answer the question. So, velocity of B relative to the ground along your y-axis minus velocity of A relative to the ground along your y-axis. What's this value?
minus 30.
Minus 30. Minus 30 minus 0. So this would work out to minus 30
kilometers per hour.
kilometers per hour. Now we can draw our diagram. So, okay. So along your x-axis, you have a positive value. So it will be somewhere here. So when you're drawing it, it would be, just say that's the value. Okay? And on your y-axis, you have a negative value. So this would now come somewhere there. So you draw your parallelogram, and your resultant would be basically that. So this is 11.962, 30, velocity of B relative to A. You may understand all of that? Yes?
We don't expect minus 30.
No, because now this here is basically just showing
Hey,
yeah, magnitude only, not because the negative is just for direction. But now that we got the direction, it's fine. Okay? But if you want to, you can show it, but when you're doing your calculations, you'll see that the negative will cancel out for itself. Okay? So, velocity of B relative to A. Oh, how am I going to solve this now?
Wait,
Using what? Theorem of Pythagoras, right?
Oh.
So this will be squared equal to velocity of B relative to A on your x-axis squared plus the velocity of B relative to A along your y-axis squared. This will be equal to the square root of this entire part, which should be 11.962 squared plus 30 squared. What will you get?
Calculators.
32.297.
32.297
297.
kilometers per hour. For your angle, where you want to take it? Here.
We normally take the top one.
You take the top one, right?
Yeah.
Okay. So tan of your angle will be equal to the velocity of B relative to A along your y-axis all over the velocity of B relative to A along your x-axis. Agreed? Yes? Opposites, that's your y-axis, adjacent to x-axis. Right? This will now become 10 to the minus 1 of 30 over 11.962. That's angle, and what you get?
Uh, 68.26.
68.2. Give me what is it?
61.
261 degrees. Right. So your final answer would be what? The velocity of B relative to A is equal to 32.297 kilometers per hour, and in your angle will start from where? East. It will be east 68.261 degrees south. That's your answer. Stand.
Hey, that's a long route. calculation, this man.
Yeah?
It's a long calculation.
It's the same thing. It's the same thing you did the last time.
No,
Extra step.
it's got extra
No,
steps.
but see, the only thing that you see this part here, I only drew this because I want to show you how we got to that. The only thing that you would change is when you come here, you just say magnitude, cos of the angle, done, and then you get your number, and then you just keep on moving, exactly like how we worked at the other questions. See, from this part here down and that part,
Yeah.
you shouldn't have an issue with that part. It's just the introduction of this part. Okay, but when you're watching the video stuff later again, when you'll see when I broke up this line to there, this has nothing to do with that part. This is just basically showing how this line was formed because it was formed from a vertical component and a horizontal component. Okay. So yeah, so this is the type of scenarios you would expect in your paper. Okay, they tell you a bird is flying north 30 degrees east, and then a wind starts to move from south 30 degrees east. Calculate the velocity or the resultant or something like that. But it's still the same stuff, methods. Because you worked out, you basically saying it's this angle, right? But this angle here is 90 minus whatever this value here is. So this value here is like 21.739. So if you said south 21.739 east, that would be the answer. If you're looking at this part here. You understand?
At least you can visualize it anyway if you feel like it's more before.
No, you can, but you need to make sure that the angle you say.
No, what I'm saying is that you visualize it in terms of if you did draw that thing, right? Where it's 30 degrees down and 30 whatever, say centimeters, and you put it 11. If you look at the way the angle is or something, it would be that the bigger angle would be the 68 degrees. So it is 68 degrees south. That's the way it works.
Yeah.
That's how I look at
It's just that we're not drawing very accurately here because it's hard to
But
calculate
if you actually-
exactly 30 degrees. Yeah.
Yeah, you can actually visualize it.
You guys, I got the pictures of my.
Yeah.
Yes. Okay, so that was our relative velocity. Okay, so now we looked at resultant velocity on the first day, so I'm just going to briefly go through it again. I'm on page 15. Let me see what's going on. Yeah. Guys, so resultant velocity. They tell you that your resultant velocity should not be a new concept to you because we have dealt with it before. But what is new is the type of question that could be combined with your relative velocity. The resultant velocity is the sum of all your velocities, and if the velocities act in the same line, they are simply added algebraically, right? So if you got like on page 15, right? So if you got something moving in this direction at 15 meters per second, and if you have something moving at that direction at 3 meters per second, your resultant velocity will be equal to 15 plus 3, which would be 18 meters per second. Right? Remember we covered this on the first day. Right? So let's look at example 1.8. So example 1.8 tells you So example 1.8 tells you that a bird is flying due north with an airspeed of 8 meters per second. So the velocity of this bird is equal to 8 meters per second. Then they tell you that, calculate the resultant velocity. The wind is blowing at 5 meters per second from south 45 degrees west. So your wind is coming in this direction.
and the angle that it would form here is 45 degrees. So the velocity of your wind is equal to 5 meters per second. So let's discuss our directions. We're going to take north as positive, south as negative, east as positive, west as negative. Right? So, how would remember when we did it earlier, we basically just said you work out the sum of your horizontal components, sum of your vertical components. Yes? Do you all want me to just go into like how they did it, or you want me to do each one individually? What? Individually. Okay. So the velocity of B, it's horizontal components, right? So x will be your horizontal component. Yes? Yes. Would be equal to what?
Would be about
Zero.
It is 0 because what? There's no horizontal component to it. Right? Then your velocity of B on your vertical component would be 8. Positive 8, right? Meters per second. Now, your velocity of A along your horizontal component, how would you do that?
You don't say
Calculate.
W by A.
Yeah, double the A.
No, you work out the wind now, isn't it?
Yeah. Right. A. Oh.
Let's break it up.
Right. How would we get that horizontal component?
So to be horizontal is
So we're gonna have to use sine and cos to get it, right?
Yeah.
So I'm gonna break up this line, right? I'm just breaking up this line. So this is the line that we have. The velocity of the wind is equal to 5 meters per second. So this line goes there and then it goes there. So this angle that's formed here is 45 degrees. This here is your velocity of the wind along your y-axis and the velocity of the wind along your x-axis. Right? So now you can all see it. So how would we get the value of the velocity of the wind along your x-axis? You would say
it'll be cos, cos on the x.
that's
So
how
it'll
we
be,
start this.
45?
45.
no, it'll be 5.
No? So how would we do it normally, guys? If you want,
It'll be 5
write down the
cos-
formulas, right? Cos of an angle is equal to adjacent over hypotenuse, right?
Yeah.
In terms of this diagram, cos of the angle is equal to the velocity of the wind on your x-axis all over velocity of the resultant velocity, basically, right? So if you want to make this the subject of the formula, you're going to end up with that.
W cos, yeah.
Yes? Yes. So here I asked you for the velocity of the wind along your x-axis. So how would you write that down? Substituting values?
Yeah.
How would you do it?
So it'll
It will be positive 5. Why? Because that is moving in a easterly direction. We took east as positive. So this would be 5 cos
45.
45 degrees, which would be equal to what?
Cos 45 from how?
3.54.
Meters per second. Now your velocity of the wind along your y-axis. So in this instance here, sine of your angle is equal to opposite over hypotenuse, right? In terms of our diagram that we have, sine of the angle is equal to velocity of the wind on your y-axis all over the velocity of the wind. Making that the subject of the formula, you will say velocity of the wind sine of the angle is equal to the velocity of the wind along your y-axis, which is what I asked you here. Now substituting your values. What's the value to substitute first? 5. Positive or negative?
Positive.
Positive 5, right?
With the same answer.
Sine,
No, it's not.
it won't be the same answer.
It's gotta be the sine.
That's the same answer.
Same answer, 3.5.
Yeah, same,
So
same.
45 is the answer.
Sine.
Yeah, fine. Sine and
Yeah.
cosine, fine.
Yeah.
So do the same. How do you comes? 3.54 meters per
45
second.
is
I did mine complete, that's why
It's a sine 45.
I read to the I didn't do break it up into these parts. Right. Now we want your vertical component and you want your horizontal component. Right? So your vertical component, okay, so v of x, because we're looking at your resultant here, right? Would be equal to the velocity of the bird along your x-axis plus velocity of your wing along your x-axis, right? Similar to what we did now in the examples. Is everybody seeing this? Are we fine?
Yeah.
Yeah.
Right. This here would now be 0 plus 3.54. 3.54 meters per second.
Oh, the difference here we're not using relative.
Yeah, it's not relative to anything.
Yeah.
This is just
that's
resultant.
the thing to change from our
Oh, yeah.
Yeah.
Right?
So you don't put the
It's not relative.
No,
Only.
no,
Now
no.
I.
It's not, you're not looking at relativity here.
Okay.
Okay. Then the velocity of y, which is your, so I'm just gonna put it in there, right? This is your horizontal component. This here is your vertical component, right? This would be equal to the velocity of the bird along your y-axis plus the velocity of the wind along your y-axis. So, substituting your values, it's going to be 8 plus 3.54, which is 11.54 meters per second. Right? Cool. Then
X-axis cuts again.
but you'll see once you get used to doing this, right, you'll eventually just work out the sum of your vertical components and your horizontal components.
So you have to be careful when they ask you for the resultant velocity
And
or
the
relative velocity.
Yeah. But
There's
they'll
a
say you can
different
see it
thing.
in the question.
Yeah, so you have to be
And
aware.
you know it because they'll say calculate the velocity of A relative to B. Or they'll say calculate the resultant velocity.
Oh.
Right? They won't ask you
Oh,
to.
okay.
Right? Okay. So now you can draw your theorem of Pythagoras. Draw your theorem of Pythagoras, you cannot draw the triangle, right? So your x-axis is a positive value, which will be that. This here would be 11.54, 3.54. Do your parallelogram. This here is basically your resultant value. Yes? Yes. 11.54, 3.54. So you'll say now your resultant will be equal, okay, the resultant squared will be equal to the horizontal component squared plus the vertical component squared. Substituting here, you're going to end up with 3.54 squared plus 11.54 squared. What you end up with? Nine,
12.07.
12.071 meters per second. And then our angle, we're going to work on this angle here, right? So, tan of the angle will be equal to the velocity, I mean the vertical component over your horizontal component. The angle will be equal to tan to the minus 1 of 11.54 all over 3.54. What do you get?
35 should be.
It's 351. 12.53.
72.94.
So 2.95. What you got? 72.9?
46.
946 degrees. So when you're writing down your final answer, the resultant will be equal to 12.071
Meters per second.
meters per second and then you would say east 72.946 degrees north. That's your answer.
Okay, but you still have to give the answer in the right format.
Yes.
Just that you don't do all that other working. Yeah.
Right? So you'll see on how the textbook did it, they basically just did the sum of the vertical, the sum of your... The more examples you do, the more you'll get used to breaking up this part here, and then the more you'll be able to see the breakup once you look at your diagram that you draw. But for now, work it out with each step. And as you get more comfortable doing it, then you can cut it out and do whatever you need to. Okay, okay, take that done. Now pause it so you can take it down, because now the video is going to be a long video with just half an hour of right?
Okay, I posted it.
Now before we carry on, right? Okay, tell me when you're ready. You're ready?
Yeah.
Yes. Okay, let me take this out, right? Now remember I told you about something called the sine rule and the cosine rule. Don't mix it up with sine and cos. Right? I'm going to show you what the sine rule is, I'm going to show you what the cosine rule is. Right. So, see you have a triangle. This is A. Okay. Now your sine and your cosine rule is used to either calculate angles or sides. So your cosine rule is equal to a squared is equal to b squared plus c squared minus 2bc cos of a. Now, capital letters indicates angles, small letters indicates sides. So you can see specifically how I wrote it. Capital letter A, B, C, small letter A, B, C. You all saw that, right? And then you get your sine rule, which basically states that sine of angle A over side A is equal to sine of angle B over side B, which is equal to sine of angle C all over side C. Now, why are we learning this? How do we use it? So the same example that we looked at just now, right? Where we had your bird flying north and you had your wind coming from a southwesterly direction, right? What was this velocity of the bird?
5, I think.
8. And this velocity here?
3.
5.
Well, one.
You're looking at the right question. Right. And this here was 45 degrees. Okay. This line that's formed here, wouldn't that be your resultant? Yes?
Yeah.
Yes, right? So this is your resultant line. Okay? This angle, this entire angle that's formed in this triangle would be what?
90 plus 45.
90 plus 45, which is what?
135.
135. Right. Now, with these rules, if you know two sides and one angle, you can solve for the third side. If you know two angles and one side, you can solve for the remaining side, and vice versa, that sort of thing. Okay? So how do we use it? So, let me get a color. If you want to know the resultant of this line, right? Let me start. So this here would be angle A, angle B, angle C. Your corresponding alphabet, which will be your side, is directly opposite of your angle. So in this one here, directly opposite B is this line here. This would be B. Directly opposite this angle here is your resultant there. And then directly opposite this angle here is C. Fine. Yeah, you would have learned it at some point. Right? Now we use this formula here to work out what that is. So remember again, the formula is a squared is equal to b squared plus c squared minus 2bc cos of angle A. A squared is equal to b. What's the value of b? 5 squared plus value of c is 8 squared minus 2. The value of b is 5 and c is 8, and then okay, I can't put it there, but it's cos of 135. Right. Put that in your calculator, what you get?
น้องมองอะไรอยู่ตึกเราจะได้รู้โจคอสแล้วโอ้เป็นสิการคุยเลยOkay, 2 times 5 times 8 times cos 135 minus 56.
Okay, so you're gonna put it exactly. I don't know. I don't know what.
12.065.
You square root it already.
So it's 25.
What was before you square root what you had?
64
This is the old thing.
64.
1, 5, what?
5, 6, 8.
5, 6, 8, and then square root this.
$12.065.
145 more than 2.
Square root this one.
Yeah.
What's the decimal same as 0.65 meters per second. That is your resultant there. Yes? And remember what we did when we worked out here? Well, more or less the same value. We have the decimal, but it's the same value.
Almost same value.
Then, oh, okay, over here it's different because of these decimal points that we took.
Oh,
If we took every single number up until a certain point and we substituted, we would have came to this exact same thing.
No,
Right?
okay. So
If
that
we
could
would have come back to the same thing. Right? So you see when I told you there's two methods to work it out. Right? Now you want to know how to show the angle. Like how we show.
How did you get this 145.568?
This whole thing here in the calculator.
Yeah. Punch in your calculator and see, because I'm getting 209.
Let's go using your phone.
Right. So open bracket 5 squared plus 8 squared minus 2 times 5 times 8 cos of 135. 145.568545. Let me see what you're doing here.
Cancel this.
But you're using your phone, that's it.
Yeah, that's a scientific calculator.
It's not the same one when you do it. You need to show that the right brackets are.
You're fast with this thing, right?
Yeah, no, do it for long. Right? So you square root it, you get that number there. Now you want to know your angle, right? So your angle that we basically, so this is your resultant line. So we basically want to show what that angle is, right? Right. So that should be right. So remember something. What will this here be? This outside portion.
45.
It would be 45.
Oh, yeah.
Because remember, when we started with this, it was 45. So if you draw it to a certain point and you cut it there, it's going to cut that point also. If you draw it to another axis, at any point you could draw axis there, it's always going to cut it at 45.
But assuming it's parallel to the axis, the original one.
Yeah, but the guy is that if you, as long as you draw your axis at
I know what I'm saying.
perfect, yeah. Right? So, we just need to know the value of the C, and the value of C plus the 45 will give you the angle of your resultant. Yes? You understand what I'm saying?
Yeah.
What shall I say?
You're saying adding the angle.
Okay, so
The angle of the
what I basically did here, right, was I want to show what angle is my resultant formed at. Right? So I drew an imaginary axis here, right? And now we know that from this x-axis up until that point there, that's going to be the angle that will tell us what our resultant is. Yes? Okay. Now this outside portion here, I said it's 45 because of, you understand what, how it's facing, right? Now when we work out this value of C, this value of C plus the 45 will give us the entire angle. Okay? So that's what I'm going to do. Now how would I do that? I would use this part here. Okay? So over here you either need to know two angles and one side to work out a side, or you need to know two sides and one angle to work out the remaining angle. Okay? It's not, you don't have to use this entire thing because it's sine A over A is equal to sine B over B, which is equal to sine C over C. So you could either say sine A over A is equal to sine C over C. You could have said sine A over A is equal to sine B over B. You could have said sine B over B is equal to sine C over C. So in this instance here, I'm going to use, well, I obviously need to use C because I'm trying to solve for angle C. So I'm going to use maybe, let's say sine, and the only other angle I do know is this angle here, which is 135. Right? So I'm going to say sine A over A is equal to sine C over C. What's your value of sine A?
135.
I mean, what's the value of A actually? Let's say it's supposed to be a small letter. Your resultant line is 12.065 equal to sine C over, and then your side C is 8. Okay? So put this in your calculator.
Sine 135 is 0.707 divided by 12 point. What? It's the same, okay.
Then multiplied by 8. And then shift sign that number. No, you see, you don't have to write it up. You don't have to write it up. So what you need to do is, like how you see how they got to answer this, you say shift sign your previous to that, give you a previous answer. Oh. Okay, so it would have been, you say sine of 135 all over 12.065.
0.46.
You multiply that by 8 and then you shift sine that there.
0.469.
Yeah?
Equals
The angle.
6 times 8.
But the pi chart, that's 0.46.
No.
That multiplied by this. Okay guys, let me just write them
That one is,
It should
one
come
is
to
0.8.
8 sine of 135 over 12.065 equal to sine of C. Give me what this value comes to.
Sine of.
Sine of C is now equal to
0.4.
0.469.
Yeah, so what's that?
0.469.
what it is?
0.469.
0.469 blah 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 blah, right? Shift sign that number.
Yeah, that's what I was supposed to do after that.
So you press shift sign and then the ans button because that gives you your previous answer. Right?
Antoine, you know Antoine.
Okay, so see what I got in the bottom, right? 8 sine 135 12. So you can open the bracket, 8, open another bracket,
Sine 135, close the brackets.
Hey, my
And
man.
watch it.
Scientific calculating umbrella.
Close it. And then I say shift sine. This answer button here gives you your previous answer. That will give you your favorite. But if you want to do it individually, how you do it? Just sine 135.
zikhona
How you
zonke
go?
uvula
12.06.
So what do? You say when you got this answer,
Yeah.
you say shift sign.
Multiply that by 8. Then you say shift sine the answer button. So if you have to write it. Do you understand that? Yes, sir.
Yeah, I just. It's a lot.
27.96.
Okay, so your C is equal to 27.96.
96.
And then remember, I told you here that your angle that you want will be equal to 27.960 plus
45.
45, which is
72.
72.960 degrees, which is more or less what we got there. Right? So therefore, your resultant is equal to 12.065 meters per second, and then you're going to say east 72.960
No.
which is what we got over there.
Yeah.
So there's two methods to work it out. The method that we normally use is the Pythagorean method, and then this here is your sine or cosine method.
So you can just choose.
You can choose between either or. This here is a fairly quicker method, but you need to remember that the way you draw your diagram will determine how your answer comes out. This method that we use is a more of a guaranteed way of you knowing your answer because you're actually breaking up each component. This is more of a shortcut method.
Cut is better.
Oh, this is a
Shortcut gets you something.
So
Yeah, it's all. Both will give you the same answers, right? But the more you practice it, you'll see you will get. You'll see past two papers in the memos they use this method, right? But they want to be quick with it. Okay. So far, whatever we covered today, guys, are you okay?
Yeah.
Just step by step.
Enough for today.
Yeah, but this year you can practice this, right? And you will get there. So we've covered relative velocity. Tomorrow, next week, I'm going to look at that example 1.11. So your homework would be question 3 of activity 1.2.
wait, go slow down.
page what?
What page?
Yeah, no, this would be for. So this is activity 1.2, question 3.
Page 14.
14.
Page 14.
Activity 1.2, question 3.
Question 3.